Thank you so much for joining us today. I'm Marcia Minke with Sunwise Power and Battery, and we're really excited to offer you today's webinar on the importance of using the right charge controller and a battery-based or a UPS power system to maximize your power. We'll cover the differences between several Morningstar charge controllers and how they were used in 3 diverse system applications that we will outline. Before we get started, we welcome your questions, and we will address these in our Q&A following the presentation. You will be in listen-only mode during the presentation. Please use the questions box on your dashboard on the right side of your screen for submitting questions. Okay, Amy. Next slide, please. Okay, leading our discussion today on charge controllers is Mark Perry with Sunwise Power and Battery and Doug Grubbs from Morningstar. Mark is one of our sales executives with vast experience in remote battery-based power systems and industrial components. He has been selling systems and components since 2009 for applications all over the planet. Doug is an application sales engineer at Morningstar and is involved in Morningstar's regional and global sales engineering. He is experienced in battery-based solar power systems and has served as an electronics engineer with the Federal Communications Commission for 9 years. Welcome, Mark and Doug. Mark, can you tell us more about Sunwise Power and Battery?
I certainly can, Marcia. Thank you so much for that nice introduction, and thank you, attendees, for joining us. Just a real quick overview of what Sunwise Power and Battery does. We are basically a power company. We will figure out how to put power in pretty much any place on the globe. So in today's discussion, we're going to talk about some pre-engineered and custom battery solutions. But again, most of this stuff is for off-grid solar systems. We also can do hybrid systems where the loads are fairly large and we need a generator involved. We've got a number of appropriate sort of solutions, of which we're going to talk about today, which is the Power Ready. It's essentially 1 to 75 watts continuous. In southern, southwestern states, you can get up to about 100 watts continuous. Northeastern states, it's going to be about 75. Power stations in the middle there, that's sort of the larger, anywhere from 100 up to, essentially that right there I think was a 2,700 watt system. And then Power Online, which is essentially an uninterrupted backup supply, which essentially uses utilities to charge batteries, and then when needed, they kick in. So that's kind of what we do. Doug?
Thank you, Mark. Thank you, Marcia, and really happy to be here today and sharing with you about Morningstar solar controllers and inverters. We've been supplying off-grid solar and equipment, charge controllers and inverters for over 20 years, and many of our installations were set up with Sunwise as our partner, and they've proven to work in a variety of very remote and rugged environments. We are 100% focused on our core competence of off-grid solar, and we have patented technologies that are designed in the U.S. with our engineers, and our engineers continue to develop and improve our new and existing products. We are expanding our engineering staff, and so it's a proven technology, and we continue to develop and improve and expand our capabilities. And thank you.
So this next slide kind of identifies why do you want to use solar for powering stuff. You'll note that in the photograph, that's out there that's in the oil fields of Texas, and there's a lot of energy floating around, but none of it's really usable. So what we do is we provide the solutions for providing power off-grid. And in most cases, bringing utilities to the location where you need the power is terribly expensive. Some calculations put it $50,000 per mile above ground and $100,000 per mile buried. That's if you're actually anywhere near it. In most cases, if you're too far away, the utilities won't even comply. They'll just say, not going to do it. Another good reason is that the equipment that you guys have in the field can be driven by direct current or by AC. So it's, you know, either way, we have the ability to go DC or AC. And so that's a nice, you know, flexible application. Some folks don't even get out to these things but maybe once a year to brush off the dust. So these locations in many cases are not attended. You know, there's nobody around, and they just keep plugging away. And then in a lot of harsh environments, we obviously have had some of these, you know, systems out in the field since 1991. You can kind of see on the next slide some of the rugged environments that we are involved in. California, that was in the Mojave Desert. Antarctica, that was a power station that actually was put up and is still there and actually tracks penguins with some tracking devices, I believe, that the U.S., I think it was the Geological Service, did something with that. Tajikistan, that was a monitoring of the ice flow there. In Peru, that was a tectonic plate monitoring, more earthquake stuff. There in Indonesia, that was a very remote airport, and they needed communications. So we did a small system for them to be able to land their airplanes. And then Florida Keys, that was at, I believe, Dry Tortugas, and that was a national monument that was running generators, and they were tired of dealing with the breakdowns, the shipping of the diesel, and so they switched out to a very low-profile, hurricane-proof, augured into the sand power station. That's a big power station. You can see the brakes within the panels. That's actually to accommodate high wind. So normally we wouldn't have those big breaks in the modules between each module, and that's just to accommodate wind flow. So those are a few of the things we've discussed here. You know, we've been dealing with a bunch of industries and doing that with Morningstar as a partner. And we've been almost, well, I think it's 15 to 18 years now that we've been working with Morningstar. So they are able to help us help you guys. They have a great engineering team, and we work closely with them. We'll cover some of the specific applications coming up here, but we're going to start the next slide with gas and oil. So in this application, the customer really needed a solution for monitoring the gas flow. You'll see some pipes there and whatnot there. They needed to know how much was flowing through the pipes. So what this was a power-ready system that their equipment was a data, radio, and valve controller. And so what you'll see here is that it was unattended. So again, that unattended thing, nobody was going to be there. It was in a desert environment, as you can see by that photo. These guys needed this to be 24/7. You know, they could not have these things go down because it costs money if they don't have it running. In some cases, in the drilling environment, if they're down, it's $30,000 a day. So nobody wants to lose that, you know, by having a small system out there that doesn't, you know, put up the power. Then the installation ease was obviously very easy. You know, all you do is you plug down a 2-inch pole, and they had two boxes there. One was their controller, the other one was the battery box, and that I believe is about a 110-watt module, and that did the trick. So moving on to the applications, Doug, why don't we talk a bit about the considerations for that type of application out in a remote area?
Yes, thanks, Mark. As you mentioned, so many of these applications, it's very critical. The loads are off-grid. The only thing that powers them is the battery banks and the sun. So it's really critical that you provide as much charging as possible when the sun is available. And so to do that, the SunSaver is a PWM controller, and so it optimizes the battery charging process. And It's also has a float setting, so it continues to charge and keep it at full state of charge once it's full during the day, and you know, this really helps. You know, if you're familiar with batteries, they really need to have as high a state of charge as possible to maintain the longest lifetime. So the SunSaver is designed for that. It's designed for smaller systems, like with the oil and gas that Mark showed. It has Class 1 Division 2 hazardous locations, so it has that. It won't spark and create something that could start a fire. So it's epoxy encapsulated, and it has marine-rated terminals to prevent rust. And we also provide this with and without low voltage disconnect. So some of the smaller loads may not be as critical that the batteries might, you know, need protection. But if there's any chance that you could run out of battery juice, we have low voltage disconnect to prevent over discharge. And it's a small controller, which is fairly easy to. We have DIN rail mounting, and so it's fairly easy to install and get into small places. And so, thank you.
Thank you much. Appreciate that. So the next application is what we call the Power Online. And in this one, there was a challenge in that there was no power available with the exception of some light posts that were nearby, and what they did was they tied into that lighting bank and attached this camera and some wireless equipment for traffic monitoring. And so what it really boils down to is the utility was only available at night when the lights were on, and so the batteries then charge during the evening when the lights are on, and of course the equipment is running off of that pass-through. And then during the day when the lighting bank turns off, the Power Online uninterruptedly goes into effect, powering the actual camera and then the wireless device. You know, the beauty of this one is that if you have utilities, you know, you can still run when the utilities are not there. And so this is kind of one of the main solutions that we use for a lot of traffic is the UPS. It can be continuous AC or DC loads, and we can actually go up to 48 hours. A lot of guys choose to do 8, 12, you know, 24, 48. We built larger systems. I was just talking about that earlier application where it was a four hours at 2,000 watts. That was a power online system essentially. So here again, this was a camera, a multi-directional camera mounted at the top of this, which would pan and zoom in and check. And there was a center where they monitored it, and it functioned 24/7, utilities during the evening and the UPS during the day. So, Doug, in this one, what we did was we used a ProStar and a SureSign. Why don't you go ahead and give them an idea of the functionalities and expand on these?
Okay, thank you, Mark. The UPS Power Online system can be implemented with either the SunSaver or ProStar controllers, which can handle low voltage disconnect and can also do battery charging regulation from a small DC power supply. The only thing you have to be careful of is that you have to derate the charging current significantly lower than you would with solar, because it's a different type of power source. The ProStar is a mid-range controller for 15 amp or 30 amp charging applications. There's two voltage choices of 12. This one here is a 12 or 24 volt for 12 or 24 volt batteries, and we also have a 48 volt version. This is one of our more popular controllers. It provides more information with the optional digital display that you can see there. And it's real simple to use, and it's really nice because people can get a really quick idea of what's happening with the batteries. And in this example, we also used we can also use the shore sign for the AC power, and this would run off the batteries, a 12-volt battery. And it's not like the little inverters you'll find, available in auto parts stores or at truck stops. It provides really high-quality AC power, and it's equivalent to grid power. It's only 300 watts continuous or 600 watts for 15 minutes. It automatically powers down into standby mode when there's no load, so it will reduce the self-consumption, and it doesn't use a cooling fan, so that makes it so it stays from getting all dusty inside, and also the fans will never need to be replaced, and makes them more reliable.
Very good. Yeah, I failed to mention that camera system was an AC system, so that's the reason why we use that. And then this is this was an application of telecommunications. That's a power station, guys. A pretty big system, roughly 7,700 array watts, located in the Mojave Desert, and this was for a Telecom Repeater, which was a hybrid system that used a diesel generator as well as a large battery bank. And you'll note that their array is quite high up on these large sonotubes. It was done that way to keep, because it's in the Mojave, kind of warm, so we used some of the wind as well as so allowing the wind to go through, as well as the shading from that array, kept the components relatively cool and manageable. The challenge here was that this was out in the middle of the Mojave. It's a desert environment. They needed reliable power, obviously, for a wireless communication to keep cell phones, skidding across California. It was an unattended remote site. As you can see, there's a large fence around there. So they needed it to be somewhat protected, so they put it within a large chain link fence. And the main thing was to reduce the generator runtime. Originally, this system was out there with a very large diesel generator, and it ran 24/7. And then, of course, delivering diesel to a remote area at $12 a gallon through some rugged terrain was not the best long-term solution. So what we did is we provided this large array, a generator, and again, the thing to remember is that it looks awfully large, but after site prep, that system right there with one vehicle would take 4 guys roughly 3 to 4 days to install. So it's a relatively easy installation. I don't want to say plug and play, but I want to say close, because everything is pre-built. Those arrays come in pieces. You can see there's 2 very large arrays. That came in 3 large, long crates, and then the rest of it comes in crates as well. But it's all, logistically easy to get to your location, provided that the site is prepped. The installation is relatively easy. So on this one, Doug, why don't you talk about that? We used the TRAKSTARs on this and the relay driver.
Okay, thanks, Mark. The larger telecom systems like this, they'll just have larger arrays, and the bigger modules will. So the MPPT controllers is a little different than the smaller PWM controllers that we have, and they're made to handle higher voltages and provides other advantages, such as the higher voltages make it so you can use fewer strings in parallel, smaller wires, less voltage drop, and it can operate at the maximum power point rather than at battery voltage. So then that means it can generate more power than the PWM type of controllers. you can go back. Oh, here's the showing the difference between PWM and TRAKSTAR MPPT technology. So a PWM controller operates in the shaded gray area, and our maximum power point can operate at the maximum power of the PV system. So you can size your array with much higher voltages, and you can also use different types of modules which you wouldn't be able to use typically. Many of our controllers include communications, RS-232, and then the TriStar MPPT 60 model also includes the EIA 445 serial and Ethernet for remote internet access. So that way you can monitor a lot of parameters and values at the site, and things like the battery voltage, any faults, and anything that's happening, you can be notified. And with SNMP or email alerts, and also the communications also allows you to connect to a computer to program custom settings, and we also offer a TriStar meter, which is this the faceplate replacement that you see on the right there on the TriStar PWM type of controller. And we also have a meter hub accessory, so you can use one meter at a site to monitor multiple controllers. And it's the TriStar is our largest PWM controller, and it can be configured for load control for low voltage disconnect for these larger systems. We also have a relay driver, which can be used for low voltage disconnect or for generators, automatic generator start. If you can start a generator, certain battery voltage, or that kind of application. But there's a few different reasons why you want to use a TriStar PWM or a relay driver. One of them is that you can access more information about the loads with the PWM, and our partner Sunwise has a great deal of experience with making decisions about what to use and how to use these. As Mark mentioned in the, before we started, he's looking at backup for so many hours, and it's real easy to not calculate everything right and not to take everything into consideration. So we really appreciate our partnership with Sunwise, and who is able to take into consideration a lot of the features of our controllers, such as the different presets, the basic and advanced custom settings, the temperature compensation, and our accessories, and the electronic protections and other features. And so if you want to go back to the last slide, this one, this shows a little bit more about our MPPT, the difference between our MPPT, the TRAKSTAR MPPT, and some of the other MPPT controllers on the market. There's quite a few controllers that, they're MPPT, but, they're not going to generally be able to track that well. Sometimes they won't be able to have very high efficiency, almost to the point where a lot of the advantage of MPPT kind of drops off. In addition, this slide shows the efficiency comparison. Ours uses power stages, which optimizes the efficiency at all power levels. So that way it will come on earlier in the morning and help you have higher efficiency in cloudy conditions when you really need as much charging as you can get. And then also during full power, it's still high efficiency. As you can see, a lot of these other controllers, they kind of force the components to work too hard and get overheated, and so they have fans built in to reduce the overheating of the components. And so the fans will pull in dust and debris, and you know, you take a look inside of a desktop computer, you see what I mean by the dust. You know, I was in Texas recently in a very dusty environment, and doing some looking at a lot of remote sites, and you know, there's dust everywhere. And when you open the controllers, there's like, it looked brand new, and you couldn't have told where it was. It looked brand new. So it really makes the robustness and the reliability a good choice. That's why people, you know, come back to Morningstar, and the TRAKSTAR MPPT is a really good product for reliability. So I would say that typically you'll get about 5% or more charging energy on a daily basis from the same array compared to other types of MPPT controllers on the market. So here's the products chart. And did you want to say something about this, Mark?
Yeah. So I just wanted to comment on all that good stuff you just shared with us. Really important too. This is an excellent chart that demonstrates the scope of available products that Morningstar offers and how they match up with some of our applications, which are on the left. And then you can see the multifaceted product line that they offer on the top. And this chart is meant to be a starting point or a guideline for selecting the right controller for your project. And as you've learned, as we've discussed, Morningstar has developed their product line for many years, and they've been proven reliable in all of these markets. They work very closely with our design engineers for proper charge controller integration for our systems, which is one of the benefits of buying a system from us. Doug, do you want to add anything else to that? Can you go back to that chart, Amy, for a second? Did you want to add to that?
Thanks, Marcia. So like Marcia was saying, it's a good guide. So, you know, depending on your application, this guide will generally steer you in the right direction, though there may be exceptions for any of these applications. It just really depends on what your load needs and what the battery bank and all that. So it really depends on the exact need of the system. So but I just want to mention a few of the products we didn't discuss yet. Is starting from left to right, the TRAKSTAR MPPT 600-volt controller is like the TRAKSTAR MPPT, but it allows for a much higher input voltage. So it's good for when you have long-distance runs, wire runs, and you could save a lot on the combiner boxes and the balance system components. The SunSaver MPPTs are small, 15-amp MPPT controller. It has low-voltage disconnect built in, and it has programmable lighting control, which is a great feature. And then our Sunlight, or I guess going from left to right, the SunSaver Duo allows you to charge two separate 12-volt batteries with a single PV module, and it's great for RV and marine and mobile applications. That's why it's in the military, I would think. Our Sunlight features 9 presets for lighting control, including dusk till dawn and evening timers with and without pre-dawn timing. So like bus stations and things like that use that a lot. And then finally, the Sunkeeper and SunGuard can both be installed outdoors. So they're completely enclosed. The Sunkeeper is also certified for hazardous locations for oil and gas. And the SunGuard is the smallest controller that we offer with only 4.5 amps of charging. So the reliability of these products has been, our engineers are the kind of engineers that do it the way that industrial engineers would want them to do it, with all the protections built in and automatic recoveries, and you have the right settings and system components so you'll be able to rely on these products for many years in these places where you know, if you have to go out in a helicopter or something like that, or you have to go to an island, you know, even places like that, you know, people are going to go for the products that they really depend on for those applications, rather than something that you'd have in a car or in your, you know, you might be having a cabin also. Although our products will perform great in any location, but we design it for the worst case scenario.
Excellent. Thank you.
So, Marcia, I just wanted to chime in here. Going back to that Morningstar products list, there's 8 applications. Believe me, there's probably a dozen per each one of those 8 applications. So that's not, but that is essentially a good jumping off point. But if you guys out there have an application that doesn't match this, that's not a problem. We do it all day long. So I just wanted to make sure everybody knew that that wasn't the limitations of what Morningstar or Sunwise can do.
Great, thanks. Yeah.
Yeah.
Kind of a snapshot, but so much more. And we can't emphasize enough how important our partnership is with Morningstar, and this slide speaks to that. We go to them for our charge controller needs, and it's really been a true partnership over many years. When we design our systems, we use the proper charge controller based on engineering specs. These are documented, pre-tested, and extremely reliable, as Doug just talked about. Mark, can you talk a little bit more about components versus systems? This question comes up quite often.
Sure. So just so our attendees know, we have a full line of components that we also sell directly to those that are in the OEM business or making their own types of solutions. But what I always stress is that within a solution, we're going to toggle back and forth between this slide and the next slide because of sort of the impact. You know, we're talking about a full solution here, and then back here you have all the components. Well, that full solution that we were looking at has probably 200 various components. And you'll see modules, wires, you know, bus bars, enclosures, you know, module rails. All of these things can be bought, and then you can put them together in the field. What you're looking at here is essentially a plug-and-play power station that has essentially 3, you know, sort of a single array, but, you know, built in a 3-pack. So if you look, you'll see that those things have been pre-mounted. The wires are rolled up and ready to connect to the actual battery box, which is the one that guy is standing on. Then there's another connection going over to the right, which is the components that the customer was actually working with. So there's a load block in there, as well as all of their different pieces of equipment. So again, toggling back to the previous slide, yeah, you could do all of this, but what we try to do is say, guys, let us do the leg lifting on the building of the system. And by the way, that comes with a 1-year warranty, as well as all of the rest of the individual parts have their own individual warranty, which lasts the duration of the manufacturer's warranty. So if you have any troubles, you give us a buzz. If it's under warranty, we work it out, ship you the new part, and then we do the warranty work on the backside. So this is where we start every single one of our projects. It's kind of an easy starting location, and what we really need from our clients is the load. And that's a DC load or an AC load. It's just how much energy are we going to be using. We need to know the voltage in DC or the voltages in AC, the current or the power. A duty cycle, which is sometimes, well, they call that the length. So it's the load, the length. The length means duty cycle. What's the length of time your product is going to be consuming energy? 12 hours a day equals 50% duty cycle. If it's 24/7, never stops running, that's 100% duty cycle. So what we do is we use that in the calculation to size the system properly. And then location. Where is this actually going to go? You know, it can be anywhere on the globe. Generally in the U.S., a zip code works quite well. If you have international locations, we just ask for the GPS coordinates. And that way, with the length, the load, the length, and the location, that is essentially enough information for us to build one of these solutions for you. And again, this is just another quick overview of what we do. The Power Ready, again, 1 to 100 watts. It can be configured in 12, 24, 48 volts, and it can be also AC. And again, if you have kind of other voltages that are necessary, we can actually do DC to DC, so it tightens up on the tolerance for your equipment. We do temperature compensation. We also can do array wattage from 5 to 1200. In fact, even more, obviously. Battery capacities, you can see we've got a large range. And then that's going to be kind of the SunSaver ProStar controller sort of application. Again, remember that not everything is built the same way. So if you have something unique or something different, we can take into consideration the tolerances or something that might be unique for that product. So going.
Mark, I just wanted to interject that we got a question. One of our attendees says that he has a customer that sometimes it's difficult to get some of that information from, and definitely give us a call. We can help with that, but maybe you want to say something.
Sure. I understand that a lot of times it's hard to get the information from the client, but when we're really trying to size something properly, it's really important that we get these. So, we can't really move ahead without the information. We can certainly take a stab. We can give you a budgetary, on a rough idea of where this thing is going to go and what the loads are. But that will not it may or may not be close to what the final solution is once we understand what the loads are. So you have to just emphasize to your customers that we can't move ahead without understanding the load, the length, and the location. Does that help you guys? I don't know. What it really boils down to is I've had this conversation a bunch of times, and we tend to, get into some budgetary discussions, and even then that might be, 20, 30% off because we don't really have the accurate loads. So, power stations, again, 100 to 3,000 watts, same configuration. Temperature compensation arrays up to 8,200. We've done more than that in the past. Again, this is the TRAKSTAR and the TRAKSTAR MPPT. And again, we can get up to a 7,000 amp hour battery system. And of course, that's where you might dive in on a hybrid system where your loads are even higher than that. And then again, the power online, converting the standard AC power that comes in to DC power that powers your equipment, or again, could be AC equipment. And it's typically taken from the utilities, passed through to the batteries. It's uninterrupted. So if, in fact, the utilities go off, your system doesn't change. There is no on-off. It's just straight through. And again, we can have these up to 2,000 watts on a SunSaver controller. And then additionally, we've got some other resources that Marcia is going to chat about.
Great, thanks. Yeah. So we're really happy when we get these worksheets, I just have to tell you. And if you need to see the worksheet, it's also on our website, which this slide demonstrates. You can find the worksheet under Resources in our Download Center, and we have some other resources there that might be helpful, some data sheets, some engineering bulletins. If you have a chance, take a look. These also help when you're talking to customers, your customers, about that. Always love to hear from you. So feel free to pick up the phone or email. We'll get back to you as quickly as we can if we can. And you know, all of your details are really important to us. So we look at that very carefully, and then we get in touch with you very quickly so that we can get back to you with exactly what you need in a timely way.
And Marcia,
so,
I was going to mention something, if we can go back one slide. If you go to this resource center and resources and whatnot, you'll also see that there's, you know, client markets, there's also case studies, there's webinars, there's a lot of information here, and many of our clients will actually use this as a tool that after we have given them the quote, then they will come here, download some stuff, present it to their clients. Very professional looking. We're also increasing the numbers of you know, documents within this resource center so that you'll have, as a customer of ours, have the ability to go out to your customers, you know, professionally with a professional quote and additional documentation that helps them feel comfortable about their experience with you as well as your experience with us.
Thanks, Mark. Okay, time for the Q&A, everybody. We've already got some excellent questions that I'm going to read off to our panelists. Hopefully we can get to most of these. If you have questions, we will get back to you if we don't have a chance to read yours and respond. So know that it will get heard and responded to. Use the question box on your dashboard on the right side of your screen to submit questions. Okay. The first question that I'm going to bring up is, I've been looking at the Morningstar sizing string calculator, and it doesn't look like it includes the 300-watt module. Has it been updated recently?
Okay. We update the string sizing calculator about once every 6 months. We're due to update it fairly soon here. And so that was, it's about 6 months old or so. And there's, if the modules, you can't locate the module, you have two choices. One would be finding a very similar module with very similar specs, which you can just search for that wattage in the search bar. Or you can also manually enter the voltages and all the variables from the data sheet. So there's two. We updated it so it's easier to enter now for the manual entry. So it should be straightforward, just about 5 or 6 variables to enter from the standard module data sheet. So thanks for using the calculator.
Yeah, thanks. Okay, how much, this sounds like a Doug question as well, how much Ethernet bandwidth is typically used for the data coming back over the comm link from the charge controller?
Well, it doesn't really take that much data. I mean, it's not really sending a whole lot of information. It's just a few data points. So it is it's a high-speed Ethernet port, so it can work with any Ethernet connection, switch or hub or whatever you have available. So it is compatible with most any Ethernet device. So it's pretty straightforward. There's a communications document on our website that provides information about that and all of our communications options.
Okay, thank you. If the controller is rated for 40A, can I use an array max current, in parentheses, LSC times 1.25 equals 40A, question mark. If I have a combiner box fuse rating of 50A to allow for a max current of 40A, can I connect the 40A controller to this array that is protected by a 50A fuse? Or do you match the input rating current to the overcurrent protection device?
Well, this is kind of an NEC question. I'm sure the Sunwise engineers typically determine all these things to meet NEC requirements. Generally, the original sizing for the controller is accurate. You would take 1.25 times the ISC value, and that would be, according to NEC, your maximum current into the controller. One of the nice things about some of our controllers, it has that built in. Like the TRAKSTAR has a 25% overcurrent where it will actually derate the controller to some extent. But I'm not sure if that really meets the NEC code, but it will keep the equipment. It won't void the warranty if you put it higher than that rating, the NEC requirements. So I hope that answers the question. As far as I know, the wiring has to be sized a good bit higher. There's different requirements for electrical equipment and for the wiring and the breakers. You would want to talk to either the engineers of Sunwise or look into the NEC requirements for that.
Great. And this is a question about sizing for both of you. Can you discuss oversizing the array on an MPPT 60600 and where the line of diminishing returns may lie? What are the factors that determine the cost-benefit loss in this equation? Sizing is a critical piece. I know, Mark, you talked a little bit about that. Maybe you can start with that.
Yeah, that's probably a Morningstar discussion. What it really boils down to is what the environmental conditions on that. So I think that would be a question best served as a direct call, and then we can kind of address the actual issues at hand. Unless, Doug, you've got some additional stuff you want to add.
Now this is regarding the temperature and the environmental conditions? I mean,
for oversizing issues.
Okay, for oversizing. Okay. So for oversizing, MPPT is different than PWM. Our MPPT controllers can be oversized beyond the nominal charging current. We have a max charge current, but it will kind of limit the charging to the max output. So it varies with battery voltage, actually. So that's why we call it a nominal max power rating of our MPPT controllers. And so it just depends on how much power shading, so to speak, you're comfortable with for your system, or if you want to determine something like the maximum power that you'll see at the site. So in a colder environment, and it's a good tilt, you might see higher power than actually the STC rating of the modules. So this kind of thing is always taken into account by design engineers, which the main point being that it's okay to oversize. We have a maximum charging current which will not be exceeded under any condition, and then we have the NEC. I think we have information about the maximum current rating. We have a maximum voltage rating. As long as those maximum current and voltage ratings are not exceeded, then you will not, it'll be, you won't do anything to the warranty. You'll just lose some power during the day if the array's able to produce higher than the maximum charging current. So it's just up to personal preferences on a design basis, whether you want to oversize it or just keep it more conservative and get every bit of the solar power that you can possibly get. So I think it's a discussion that's more something that you see on a lot of forums and kind of things that you might find information about that also. So Sunwise probably has some. Their engineers would give you some recommendations, I'm sure. So thanks.
And Marcia, I think there's a white paper on that too somewhere. I don't know if it's the one that's posted, but we may want to get that. That's a good question. May want to get that up on the Resource Center.
Cool. All right. Thank you. All right. This is about Power Online. This customer wants to use utility as the base power and solar as extra. Is that Power Online?
That actually has been done before, Marcia, where it is typically a backup to the utilities not coming on. In other words, for instance, if we go back to the original discussion where the lighting bank is what charged the batteries, well, what happens if the utilities go out? How are you going to keep that battery bank up and running? So what we have done in the past is we have attached a PVK kit, which is essentially a solar kit on a racking system that is also tied to that charge controller and will also trickle charge as needed. Now, will it cover the total need of the utility input? That's a sizing question. If you're looking to just, gather a few hours because of the utilities, and a lot of the times utilities might go out for a couple hours. In some parts of the world, they go out a couple days. But typically in the United States, utilities are not out for more than 8 to 12 hours. So what that's going to mean is that you're going to want to make sure that the PVK is sized, that if in fact the utility is out during the day, there's going to be enough trickle from that DC input along with whatever was left in the battery banks to ensure that you're going to get the length of time you need on that Power Online usage. But yeah, it's been done. Short answer, yes, it's been done.
Okay, cool.
More of a backup to the utilities going out, not so much a freestanding solution.
Right.
I've seen people take both approaches, relying on the solar power or for the most of the time, or relying on the utility, and it's like the utility is either the backup or the solar is either, or the solar can also be used as a backup. So you can go both ways with how you want to set it up. So if you're using solar and the utility power, you can rely mostly on the solar or mostly on the utility, and you can have a utility kick in when you need it, or just power always with the utility and the solar is there if you need it.
Yeah, good point.
Okay, thank you. What kind of battery could we recommend for a non-maintenance area with a temperature over 27 Celsius?
I'd have to go back to my DECA Concord data sheets. I don't have that information immediately at hand. If we had Trojan or DECA on the line, they'd probably be able to answer that quite easily. Why don't you reach out to me directly and I'll get that information.
Okay, yeah, we'll make sure that that happens. Okay, what happens if I exceed the nominal wattage ratings of your MPPT controllers?
I think we answered this question already. It's okay to oversize. You will not do anything to the warranty. So the main thing is the voltage and the current rating of the array you're connecting. But it's just a matter of how much limiting of the maximum power you're comfortable with. You wouldn't. Some people may be fine with losing 20% of the array power when there's that part of the time. Other people would say that's more than one. I want to add more solar controllers to that array. So it just depends on how much you need and a lot of considerations for the design engineer.
Okay, thanks. We're just about at our hour here, so I'm going to give you guys one more here. Namely, this is for Doug. Why are your battery charging stages better than your competitors, and how are they different?
Well, I think a lot of people have copied our since we built it, but generally we use the standard. Oh, I think you have a slide there. I just noticed. You can go to that slide, our charging stages there. So that's it. So basically, you want to provide charging to the battery whenever you can without overcharging it, and you want to keep it from over discharging so that you got the LVD there. So generally, we have temperature compensation. We make sure that your batteries stay full. If you have an on-off charge controller, for example, that's just going to turn on and off, and and if it's turning off when you're still not full, what really you need is the regulation voltage, maintaining this voltage for a period of time, and this is just like battery charging 101. It's like just that slowly the current decreases until the battery is full. So you want to have a good absorption stage for flooded batteries. You want an equalized stage that happens like once a month, and then you also have a float stage. So these are pretty standard charging stages. I guess the difference with with Morningstar is that the PWM and just the algorithms have been well thought out, and there's a lot of options, especially with the advanced settings, to really optimize the charging. If you really want to get into getting a completely full battery, you can also adjust your settings for that.
Okay, one last really quick one here. We've heard of noise interferences from controllers in some situations. Do you have experience? How do you troubleshoot that?
Well, yes, we are several of our controllers, the SunSaver included now. If you open the cover to the SunSaver, there's a jumper wire that you can cut, and it will go to slow switching. So it will still charge well, and then it will eliminate the higher frequency PWM if there is any noise. The TRAKSTAR and the ProStar also have this feature. So this is more of an issue with the PWM where it's creating noise. Our MPPT, our TRAKSTAR MPPT controller is FCC certified for, I forget what, even though I used to work for the FCC, I forgot the rule, Part 15, Class D certified. So generally MPPTs are much higher frequency, and they're not creating as much noise as the PWM, which is switching just on and off the whole power of the array.
Great, thank you. Okay, we're going to wrap it up here. Any last words? Mark, Doug?
Well, this is Mark. I just wanted to say thank you for joining. I appreciate your time. And again, if you have any questions, you've got the Sunwise Power and Battery 800 number there. Just punch the West Coast, and that goes right to my West Coast sales, and that goes right to my desk.
Great.
And I just want to say thank you to Sunwise and to Mark and Marcia, and we really appreciate your setting this up. And thanks for tuning in. And if you ever need any help, you can contact Sunwise, or our website has a great deal of information. If you need anything, you can also contact us through the website.
Great. Thank you, Mark and Doug. And thank you, everyone, for taking time from your schedule and for your questions. You will receive a copy of the webinar recording this week, and we're always eager to hear from you. Have a great finish to your week, and let us know other topics and what you're thinking about. And again, thank you. Have a great day.